Alright, in this video I'm just going to try and finish off chapter 5.4. So the next part is looking at intersections of graphs to estimate solutions. So first off, let's consider the equation x squared plus 2x take 6 equals 0. So we can solve it algebraically, whether we want to use the um, quadratic equation or find its linear factors. We can find that x is actually equal to plus or minus the square root of 7 take 1. So that's the actual solutions. Okay, but let's just assume we can't do that. So if we rearrange the equation as x squared equals minus 2x plus 6. Okay, just taking 2x and 6 on the other side. Then we can say any solutions to the equation are the x coordinates of any points of the intersection of the parabola y equals x squared and the straight line y equals minus 2x plus 6. Okay. So both of these polynomial graphs are relatively simple to draw. So the line can be drawn accurately using the intercepts with the coordinate axes, and the parabola can be drawn with reasonable accuracy by plotting some points that lie on it. So, what does that mean? Well, let's draw our axes and draw in the graphs. So we'll say x squared looks something like this. Okay. Well, let's put some points in. So we'll say well, here's x, here's y. Actually, let's draw the other line. So minus 2x plus 6. Okay, has an intercept at the y-intercept at 6. And negative, meaning we go down. And 2, meaning it's been dilated. So just roughly something like that, and that goes through 6. And we have these two intercepts here of the equation, the other equation, and I don't need to know. Well, I can work that out as 3. Solving for that. So what we want to do is the diagram shows the graphs show there are 2 points of intersection. So we've got 1 point here and 1 point here. So the equation x squared plus 2x takes 6 has 2 roots. So we can say because these two graphs have 2 intercepts between them, this equation here has 2 x-intercepts. Okay, 2 intercepts here, there's going to be 2 x-intercepts there. If you got no intercepts between the equations here, means that there's no intercepts for that one. But in this case, we've got 2, so this has 2. So estimates of the roots can be read from the graph. One root is approximately x equals minus 3.6. So how do we get that? Well, to determine whether or what the intercepts are, we should have actually used graph paper, because there's no real easy way to work it out in this case. So as a rough estimate, let's say that's about 1, 2, yeah, no, let's scratch that. Okay, let's use some coordinates. So I actually should have put them in. So let's go 1, 2, 3, minus 1, minus 2, minus 3. And we'll go 3, 6, 9, 12, 15. Okay, x squared graph. It'll go through 1, 1, 2, 4, which is about there, 3, 9, somewhere there. And then similar on the other side, -1, so 1 and 4 and 9. It's about there. So connecting the dots. Okay, that's our x squared graph. Now our 2x plus 6, negative 2x plus 6, okay, goes through the point at 6. Now we have a x-intercept at 3. So drawing a straight line between them. Okay, roughly there. And I haven't done this very well. 3 should be there. So this point here is about, okay, about 1.5, 1.6, roughly, just from the graph. So go one across, that's our x. And this one, I haven't done it very well, but it actually should be, if we use graph paper, x should be roughly about 3.6, and we just read that off from the graph. So it should have, it's not very well, a bit off, but it's just how I've drawn the graph. These aren't very spaced out properly. So just reading from the graph, we get our 2x coordinates. That's our estimate for the actual coordinates of this equation here. And if we actually worked out, because we know this is the actual solutions, we actually get 3.646 or something negative, and x equals 1.646, so it's close. So here we get something very close to, or we should get something close to these two solutions. Now on page 242 there's a bit of a summary in yellow. I'm not going to write it all out, so you can just copy that. It's a good idea to copy that in your books. So we've got to use the graphical method to solve the polynomial with equation h of x equals 0. So starting off, rearrange the equation in the form p of x equals x of q of x, where each of the polynomials p of x and q of x have graphs that can be drawn quite simply. So in that example, p of x would be x squared, q of x would be the minus 2x plus 6. Second part, sketch the graphs of p of x and q of x. And it says with care there. I didn't do it with care. And you saw how much problems that caused. So if you got graph paper, good idea. If not, use your ruler and scale properly. Part 3, step 3, the number of intersections determines the number of solutions. So we had 2 intersections, so we're going to have 2 solutions. The x-coordinates of the points of intersections are the solutions to the equation. So we found minus 3.6 roughly as one intersection and 1.6 as the other one. So our solutions to the x-coordinates of the actual equation is going to be those 2 points for x. Step 5, estimate these x-coordinates by just reading off the graph. Yep, and alternatively, an interval in which the x-coordinates lie can be determined from the graph, and the method of bisection can be applied to improve the approximation. So we approximated minus 3.6 and 1.6. So from there, we can actually apply our bisection method. I'm not going to go through it, but if we want a more accurate